This is the Mast end cap without the screws, and this is what I'm going to show you how to add. Alright, first section is tools needed. I'm going to start with the drill bits and stuff over here. So, in order to put these in, you're going to be drilling a 9/64 hole into the actual end cap, and that is going to be what the screw threads into. I recommend some sort of coated, titanium coated, cobalt, something other than just plain steel. Otherwise, after you drill through 50 of these end caps, you're going to wear out your drill bits. Next is going to be the countersinking drill bit, which is 11/64. Again, a coated drill bit is ideal. If you notice on here, if my camera will focus, but I have some small collars. There we go. Small collars, and I put those on there just to easy set depth, so you can switch out drill bits and different drills pretty fast. You're going to need a 5/64 hex wrench for the small collars that I'm sending out. And to make it easier, put into a drill or with a drill, a 1/4-inch drill driver, hex end, and that goes to a 9/64 hex socket, which will be the size to put in the screws that we're going to use. We're going to use a 832 by 3/8. This is a hardened alloy steel, zinc-plated socket head cap screw. So a pretty long and fancy name just to show this screw. It's harder than grade 8, which means it's very strong. So here are the drill jigs. This is the main drill jig. I'm going to be going over this in a little bit and all the extra features on it. And then here is the countersinking or counter bore, technically, jig. I'd recommend 3 drills. 2 drills will work. You just have to do a tool change. One of the drills at least needs a low gearing on it, because you're going to need a drill that does not exceed anywhere, 300 to 400 RPM in the low should be fine. I'm going to show later my torque limiting sockets that I ordered in. The vice grips, big old hammer, and some coolant. So this next part, I'm going to quickly go over the drill jig and the drill bit setup. So here's the drill jig. I'll show you later. It will fit on the end of the cap and locates off the tracks. It'll fit right in. You have your drill bushings that are for the smaller size, the 9/64, that are hardened steel, so they shouldn't wear out, and they keep the drill bit nice and perpendicular to the work surface. Something I'll go over later is be careful when you're drilling this. You don't want to bend your drill off to the side. You snap drill bits that way. On here, there's 2 of these counterbored holes. I just put coolant in those. Any sort of liquid coolant works great. Make sure, I'll go over a little bit later again, make sure you keep your drill bits cool, lots of coolant. The 2 biggest things I had to show here today, right now, is going to be, this is the 9/64 drill bit. I set the depth of this one. What you do is you put your drill bit in, and the collar will be right at the end, and that will set your drill bit depth, so that when you drill into these end caps, you go a certain depth, and I will add that to the tech spec sheet. And the next one, the smaller one, this is your counter bore. So when you put these drills in, or these screws in, you want it to thread down here, but you don't want to thread it into the steel, as it'll then catch and then break off. So you have to counter bore this top steel piece. And this is what the larger drill bit is for. What you do here is you use your counter bore jig, right? You put that through, you put this up to here, you make sure it bottoms out, and then you put the set collar. And that will set your depth right here to be exactly what it needs to be. The amount this drill bit sticking out should be the exact depth of this milled slot. And that's how you set up your drill bits. Next, I'm going to be talking how to set up your work area. There are going to be different ways that might be faster and easier depending on the situation. But what I found, I can produce them pretty fast if I line 8 to 10 of them up in a row on some height, that's comfortable to you. And I can pull one out each time, drill, 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 and just go down the side, other side. And that way you can just hit them all at once. Then you move all of them to the pallet when you're done. This system can get reworked with the drill jig when the masts are vertical. They will fit on there, and then you can do everything. It will be a lot faster if you can put them down on a table or some sort of horizontal surface. Now for the fun part. All right, this is going to be the procedure on drilling. So take your jig with the drill bushing towards the outside, and you're going to line it up right towards, it should be flush with the top, and it should fit down in there nice and snug. If your track is bent and these slots have a problem going into the track, try to bend the track back if you can. Otherwise, give this a little bit of a tap with a hammer and it should seat. Grips, and you're going to clamp down one on each side. So now I loaded up the smaller drill bit, the 9/64 drill bit, with the collar into my drill, high-speed drill setting, and I'm filling up the reservoirs here just for some coolant. Like I said, this might not work for every situation, but it works for this one. So I dip it in. So I drill one out, all the way down, take some more coolant, drill the next one. A couple things I found, going through the steel plate, it's going to get kind of hot, your drill bit is. Don't push it too hard, but nice even pressure. When it hits the aluminum, if you're pushing too hard or if the drill bit is too dull, the aluminum will adhere to the end of the drill bit. Just pull it up, put it down, pull it up, pull it down. Do that a couple times, you should be able to take the aluminum off the drill bit. Again, make sure when you're holding this relatively perpendicular. I mean, the drill bit will want to center itself, but if you do this, you're going to snap drill bits. After you're done with that, you can rip these off, and now we're going to do our counter bore. So I loaded up the larger 11/64 drill bit into here, and now what I'm going to do is I'm going to put this on the end, just like so, and then I'm going to hold this. I'm going to try to show it on camera here. I'm going to hold this while I'm going to use that and drill out these two holes we just drilled. We're going to make them larger so it can sit in there. So this is just an example. While holding this piece, the jig with your hand, you're just going to drill these out, and that's going to produce a perfectly drilled counterboard hole that's not going too deep. You can look, my camera will focus, you don't want to dig into the aluminum. You just want to slightly touch it. Otherwise, you're going to kill your threads or kill your possible threading surface. All right, once you drill the holes, just take some sort of air source, pull out, and this is when you're going to add your two screws. Now, when you're done, if you see on this one, it's not fully seated. You need to touch that one up a little bit. Make sure you don't snap a screw. Again, torque limiting socket is the best, and then torque wrench is backup. It should be fully seated and torqued down. The screws might stick up just a little bit off the top surface, but ideally they should be darn close to flush. All right, here's an example of a snapped bolt right here. This gets a little tricky. What you're going to need to do is take your drill jig again, put it right back on like it was, and you're going to have to drill out that screw. Now, this is a hardened alloy steel screw, which means go slow, uses a lot of coolant, and you might just have to eat a couple drill bits. Not on this one, but if you do it multiple times. Once you drill it completely out, reset your drill bit depth to deeper, go about at least another 1/8 inch deeper, and then put a longer screw in. The screws we are using are 3/8 length. I would recommend if I might be able to find 1/2 inch before I send it out to you, Will, but if not, find a longer screw. Make sure it's alloy steel. Stainless is going to snap. You can use stainless. You got to lower the torque and just take it nice and easy. All right, I'm going to show you how to adjust the setting on the torque limiting sockets to different torque limits. Here's the bottom of the torque limiting socket. And what you're going to need to do is you're going to need to take this snap ring off, and then see there's this plate that's shaped like a gear. You're going to pop that plate off, and then you're going to be able to take a crescent wrench and turn this centerpiece, put the plate back in, snap ring back on, and you've successfully adjusted the torque setting. So you're going to remove the snap ring with your snap ring pliers. Now normally you should be able to just take this upside down, hit it a couple times, and the spacer falls out. This is your locking spacer. This keeps the torque setting where it should be, even if it's dropped or if it's torqued really tight. And adjust it by taking your crescent wrench and spinning it counterclockwise or clockwise. After you put it all back together, you can put this in a vise to check the torque. You want to clamp it down on the smooth sides, just enough to keep it in there. And then you're going to take a inch-pound torque wrench with the 3/8 drive